Okay, do you understand it's necessary to convert it to percentage to decimal? It's very, very similar to the other formula that we're using in the other chapter. No? So whenever you plug it in the formula percentage, you convert to decimal. Likewise, minus, because it's lost money, minus 0.08y plus 0.02 C is equal minus $540. Okay, let me try to repeat again the idea. Look, this expression is this expression in which you multiply the money, by the way, I don't know, I call X, Y, and Z, by the corresponding interest rate, expressed, of course, in decimal. And this give me the interest. And every interest together, bang, bang, the total interest was $540 per loss, negative. Do you understand very well this equation?
Yes, yes.
Yes. Now let's move on to the no complicated, but more tricky, in my opinion, ¿no? Equation, que es the last sentence, que es Janet invested 200 more. 200 more indicate 200 plus, no? Okay, suppose X is the money that she deposited in the bond fund, it's the first account, plus C is the money that she deposited in the international fund return, international fund. And Y, let me put equal sign here. Y is the money that she deposited in the aggressive growth. But these are not equal each other, no? The difference in between them is 2,000, no? Okay, there are many ways to write that. You adding 2,000 here in order to balance this money. Or another possibility is X plus C, que es this money and this money together minus Y, oh, no, much better like that. Y is the money deposited in the account aggressive, subtracting X plus C together is equal to 2,000, because the problem say that this money is bigger, no, than this together, but the difference is 2,000. And this is equivalent, no? Who make a noise? Hey, putting off the microphone, please. Okay, so now like this is similar or no? Let me see. Yeah, of course, similar, because you're moving X plus Y to the other side. Addition is the same. Do you understand the third equation or no?
Yes. Yeah.
Okay. It's the ID, the complicated part, because the other thing is algebra. Okay, it's a system of equation, linear, is three variable. And remember, three variable for solving, you pair two equations, eliminate one variable, and you pair another equation and eliminate one variable. But before that, I recommend put everything in standard. What means to be a standard? I copy X plus Y plus C equal 18,000, because this is a nice equation in standard. How do you know this is standard? We have one column of the X, we have one column of the Y, we have one column of the Z, and we have a right-hand side number, which is 18,000. The second equation is the same, but what is the only disadvantage? The only disadvantage is that we have a horrible decimals, but I can fix it now. Okay, when you have decimal and you want to remove clear decimal, for example, the decimal involved in my problem contain two decimal places. if you multiply the equation number 2, the entire equation number 2 by 100, this 0.04 become like a 4x. Nice, I like that. Minus AY, I like that. Plus 2C equal, entonces minus 54,000. Okay, because it's 201230. And this is my new equation 2, at least more elegant, no? More elegant. Let me try to express the equation number 3 also in standard. This is x minus y, so I move y to the other side, plus c stay in place, just bring down, equal minus 2000. And this is equation number 3, are equivalent perfectly with the original. But the original is the, the roughly equation that I obtained, or the raw equation that I obtained to read the problem and try to understand. Now this is more clear, more acceptable to start the algebra part. Okay? So I propose you one idea. You, for example, you pair equation 1 and equation 3. Okay. Why I select that? Well, I am not clear, but I believe gets better because I copy again, guys. Organization extremely important. I take equation 3. I take advantage. This equation 3 and equation 1 together is ready for elimination because this is positive y and negative y. So you adding equation 1 plus equation 3, you have 2x. Because x plus x is 2x, y and negative y is cancelled out. C plus c is 2c. And 18,000 minus 2,000 is 16,000. And this is my equation 4. However, I see, wow, I see any number is even number, right? So there are no reason to leave it like that. No. This is acceptable, but no, okay. You divide by 2 everything because it's even. So my equation is x plus c equal 8,000. Whoa, more clear. I like that. This equation 4, sorry, no 5. It's the same. Cool. Everyone follow me? Anyone follow me? Yes or no? Confusing. What part confusing? Come on.
We follow you.
Okay. Okay, so what is the procedure? I need to take 2 couple of equations. For example, in my paper, I did like that. I take 1 and 2. Okay. I copy 1 again. I copy 2 now. I need to do my best in order to eliminate the same verb. Remember, important. If you eliminate in the first couple y, you have to eliminate y in the same. So I propose you this idea. It's easy. You multiply the entire equation, number 1, multiplication by 8. Because 8 times 1 is positive 8, and positive 8 and negative 8 is ready for elimination. So I copy down ax plus ay. So I am doing the multiplication. This 8 times this, times this, times this, and of course times this. Plus az equal, let's say we have 18,000 times 8 is 144,000. And this is my new equation. Let me check it. Let me verify this computation in my calculator right now. So 18,000. 1230 times 8. No, 80 wrong. 18,000 and 8. Yeah. 144,000. So this is equation 1. It's equivalent 100%. And you right now you're adding equation 1 plus equation 2. Okay. 4 plus 8 is 12. This is cancel. That was my intention. Plus, this is 10. 8 plus 2 is 10. And here we are because it is, wow, what the hell? Is 144, I have my calculator, subtracting minus 54. Oh, it's 90,000. 90. One more zero. This minus this. Well, this is the equation 5, but I don't like this equation. You divide by 2. Why not? Divide by 2. Because it's even, I detecting the coefficients are even numbers. Not necessarily working with this big number. 6x plus 5z equal 45. 45,000. And this is my equation 5. And you put together 4 and 5. Let's do it. 6x plus 5z equal 45,000. Equation 5. And this will almost finish because right now we have a system of 2 equations and 2 unknown, is x and z. Okay, super. What should I do? Well. There are many ways, no infinity, but there are a lot of combinations. Because I decide multiplication equation 4, multiplication by -5. Why -5? Because -5 times x is minus 5x. Minus 5 times z is minus 5z. Minus 5 times 8,000 is minus 40, no? Minus 40,000. This is my new equation 4. It's equivalent 100% with the original, but I multiply by -5. You know, when you multiply one equation, linear equation, by a number, the equation is the same. It's totally dependent. Now ready? You're adding 4 and 5. This is 1x. Wow, 6 minus 5, 1. This is cancel, say goodbye. And this is 45,000 minus 40, 5,000. 5,000 is my first solution. Okay, by the way, is the money que Janet deposited in the third account, no, in the first one. This is at 4% interest rate, X. Okay. In order to find the 2 other money, well, it's easy. You go back substitution. You plug it in the easier equation. In my opinion, is this. See, I know that x is 5,000 plus c is 8,000. Basically, I am using the equation number 4. That one. C is equal 8,000 minus 5,000, 3,000. And this is the answer in the account at 2%. Okay, now I want to find the y value. So to find the y value, I recommend we can use in the original equation because we have in my hand 2 variables, x and z. Entonces I select the first one. Es obvio, ¿no? O sea, x is 5,000. You replace the corresponding plus y, que I have no idea, why I don't know. C is 3,000. Should be 18,000. Entonces this is 5,000 plus 3,000 is 8,000. Now subtracting 18,000 minus 8,000 is obviously 10,000. This is the answer of this at the account was negative 8%. That's the reason she lost money, because when I split the money, I put more money in the account. Was aggressive. Aggressive is good because you win, you have a lot of money, but if you lost, you lost money. And this is the answer. Let me verify see everything is okay or not. How you verify that? Well, this is not mandatory, but if you want to make sure that you answer good, I recommend you that you plug it in. No, of course, in the first equation, because immediately I'm using to find a y. This is something matching. For example, and the interest is more interesting. So I want to verify 0.04 multiplication by 5,000, que es x, minus 0.08 times y, que es 10,000, plus 0.02 times 3,000 should be, I clean this. Si es equal, fantastic. I am solving well. Is equal minus 542. Okay, put in my calculator this answer. This answer is 200. I put in the calculator this answer. The solve is 800. I put in the calculator this answer, que es 60. Entonces 200 minus 800 is 6 negative 600. Let's add this together. Plus 60 subtraction is 540. Cool, I got it. It's okay. Any question? Guys, I explained last time, however, I want to explain again. And when you are doing the homework online, in the homework online, we have word problems. So I understand that some students don't understand very well the word problem, but you don't worry. You send me the screenshot with your word problem. I try to help you. Okay? Okay, it's my pleasure. Anytime you send me, I solve it in 5 seconds. Okay? I can erase the board or not yet?
Yeah.
Wow. I did wrong. Okay, let me try. Now let's continue with the application of the linear system equation. But now one application of algebra is very, very, very important. Three very for calculus 2. I suppose que the majority of you need to take calculus 1, calculus 2, but this application is using in calculus 2. I want to explain in detail now. I know that the teacher que explain calculus 2 need to record that, but not too in detail. So you need to see before with me in pre-calculus. Now you're ready to take this. Okay, what is the idea? The idea is partial fraction decomposition. Let me put it the elegant title. Okay, it's a partial fraction decomposition. I want to explain a little what is that. Okay, cool. Partial fraction decomposition. Partial fraction decomposition. What is this about? Well, you have a rational function. Okay, we have 4 cases. I want to explain one by one. But let me explain the first easy case is when you, for example, has this rational function 5x minus 1 divided by x squared plus x minus 12. And you decomposition in different partial fractions. This is the new idea. What is that? Well, first of all, you factorization the polynomial in the bottom. In this case, easy because two numbers can multiply each other, give me 12, and somehow when you're adding or subtracting, give me 1, is 4 and 3. You 4 times 3 is 12, and 4 minus 3 is 1. But the sign is obvious positive and negative. So what is the goal? The goal is you separate this complicated, not complicated, but a little bit more complicated expression in 2 partial fractions. Suppose x plus 4 is the one factor separately, and 1 minus 3. But you have no idea the top part. You have no idea. So in order to find the top part, you call A and B. You seek, and there are more partial fractions, you call A, B, C, D, E, and so on. This is the goal. You understand the goal? It's decompose one complicated rational function in several partial fractions. It's a small piece, and they are equivalent to the original ugly, ¿no? Entonces es fantastic in calculus, because in calculus you need to apply different operations. Okay, then I want to explain 2 different ways to do this. One easy way, not always is possible, using the one shortcut you are doing in 5 seconds, but another is more traditional, is using linear system of equations. That is the reason the connection with this chapter, no? But not always is possible doing the shortcut. However, the linear system of equations is always possible. Let's try. In order to simplification a little bit that part, you find the least common denominator. And then obviously, Alberto. Okay, Alberto. You are late. Least common denominator is, in this example, the multiplication x plus 4 times x minus 3. Que es the multiplication 2 factors in the denominator. And now you multiply everything by the LCD. This. It's obvious when you multiply the LCD times the left-hand side, this is equivalent x plus 4, let me copy, x minus 3. You remember the factorization we did before, no? Thus I solve that everything is cancelled and stay alive only 5x minus 1. But when you multiply by the right-hand side, in the first partial fraction, it's obvious that x plus 4 is cancelled. And stay alive a times x minus. Plus, when you multiply the LCD one more time by the second partial fraction decomposition in the right-hand side, it's obvious that x minus 3 is cancelled and stay b times x plus 4. Guys, do you follow me so far? This is the most important part. Yes or no? Oh, well? Yes, Steve. Okay, Steve, look. Now, the rest is super easy. The rest is super easy. I want to explain the shortcut. The shortcut say you plugging in some smart value. What is the smart value? For example, x equal 3. Because when you plug in 3 here, look, 3 minus 3 is 0 and disappear now. Let's do it. Use substitution, x equal 3 gets smart. 5 times 3 minus 1 is equal 8 times 3 minus 3 is 0, it's gone. Now part is 0, is gone. 0 times a is 8 disappear, plus b times 3 plus 4. This is 15 minus 1 is 14 is equal to b times 7, no? Because 4 plus 3 is 7. Therefore, divide by 7 both sides, b is 2. Boom, I found at least b. Similar idea, I using another smart value that is -4. Why -4? Because when I plug in -4 here, plus 4 is 0 and disappear the b part. And I get the a part. We have in this example everything is nice, but not always is nice. We have two smart values, and using this smart value, you solving a and b, but not always happen. You see another example. This is the trivial elementary example. Let's do it. Suppose -4. -4 x. You substitution x for -4. 5 times -4 minus 1 is equal. 8 times, I am working here, guys, in that expression. -4 minus 3 plus b times -4 plus 4. Ooh, this is 0. This is 0. This is my intention. That part disappear. And stay alive only 8. This is 20 minus 20 minus 1 is 21 negative. Is equal 8 times -4 and -3 together -7. So we have -7a divided by -7 both sides. A is 3. Boom. So what is the fantastic conclusion? One of the fantastic conclusion is the answer, the final answer, final answer is this rational expression, okay, 5x minus 1 divided by x squared plus x minus 12 is equal, a is equal 3. Look, you replace this for 3 and you replace this for -4, no? No, sorry. A is 3, yeah, and B is 2. So it's 3 over x plus 4 plus 2 times x minus 3. Bang! And this is the algebraically equivalent, 100%. Now we...
Professor.
Okay. Go ahead.
Sorry for the interruption, but the picture you sent us with the email, is that the test we have to do?
Yeah.
Or?
I send intentionally for one student que have pending this because talk to me. He need to redo one specific student. I suppose that he is present now and not very well get for her. After I talk to her when the class is over. But no. For the average student, you took and you sent me the answer, no?
Yeah, but I was having problem with sending you the work. My work wasn't sending on email. Can I redo my work on that paper and send it to you?
Okay. This is not the moment to discuss in this. The moment to discuss. Listen. Any situation, I am friendly, guys. Any situation, you send me email. I read the email. I communicate with you. We negotiate by email one solution. I always find solution. Okay, but not in the lecture. Okay, in the lecture is mathematics. You ask me why 3, why 2, why 4. I explain that, right? Everyone follow me? Or no?
Yes.
However, however, I want to explain another way. Another way gets connected. You say, well, professor, but this is no, they are nothing related with the linear system of equations. Yeah. Let me explain another way to do this. Okay, but because not always it's possible to do it that way. For example, the smart value do not exist. You're seeing another example, no? And this not. Another way is you, for example, you copy one more time. It's 5x minus 1 is equal 8 times x minus 3 plus bx plus 4. And you know, no smart value, you don't know anything about this. And you apply distributive property. You multiply 8 times x, 8 times minus 3, and b times x, and b times 4. It's no big deal, it's easy. It's another way. It's always possible to apply. And now you grouping. How you grouping? Well, the guy can contain x, you group it in the same, because x is common factor. So a plus b, x, and you put together, for example, plus minus 3a plus 4. And when you compare this function and this function, it's easy to understand. Okay, a plus b, fi. Because a plus b is the coefficients in front of x, in the left hand side is fine. And minus 3a plus 4. I make a mistake. This is 4b, right? Because you multiply bx and 4b. I forgot one letter. And minus 3a plus 4b is equal negative 1. And we have equation 1 and equation 2. Let's solve it. It's obvious that the best way is using the elimination. No? If you multiply, for example, the equation 1 by 3 positive, you have the equation 1 now is 3a plus 3b equal 15. This is my new equation 1, but it's ready to elimination at least the a part. A is cancelled. This is 7b, and this is 14. No, 15 minus 1, 14 divided by 7 both sides. B is 2. Wow, look exactly like that. Now, CB is 2. I'm plugging in the easier equation. That's the first one. A plus 2 is equal 5. A is equal 5 minus 2 is 3. It's another possibility, guys. And this is the safe possibility because always you can apply this. And this sometimes. Sometimes yes, sometimes no. Do you follow me? Everything is clear or no?
Clear.
Let's do one example similar to this. So this is the first scenario, case number 1. Case number 1, in which the polynomial and the denominator contain linear non-repeated factor. So this is the scenario in which, remember the notation that we're using in the rational function of p divided by q, no? What happens? Q has non-repeated linear factor. But we have more combinations. We have repeated, we have irreducible quadratic or the complex, but no, don't worry. We see examples for everything, step by step. Slow down. So now we are doing one more example to reinforce the idea for this case number 1, case non-repeated linear. Okay, erase the board or not yet? Erase, yes? Okay.
Yeah.
I want to copy. Example 2. Example 2 is x over x squared minus 5x plus 6. What's the goal? The goal is decompose in several partial fraction decomposition. Guys, this is the continuation. After in calculus 2, when you finish that part, we start calculus, do operation with the partial fraction decomposition. But this is important in the algebra. Okay, what should I do? You take the polynomial of the denominator and factorization. Sometimes it's easy, like this example, sometimes no. Sometimes, you know, it's more complicated. Maybe you need to apply scientific division. But in this case, no. In this case, it's easy. It's 3 and 2, no? 3 and 2 because 3 times 2 is 6 and 3 plus 2 is 5. And both negative. Make sense? So I realize, wow, we are in the case number 1. We have no repeated because it's different, no? X minus 3, x minus 2, it's different, no repeated. See, I repeated as x minus 3, x minus 3, it's repeated, no? But no, in this case, non-repeated and linear. No quadratic. Quadratic is x squared plus 4. Oh, this is repeated, and this is irreducible quadratic, the complex solution. Entonces now, this is another scenario that we see in the next example. But in this case, no, it's easy. It's easy. So you break it down, decompose, and 2 partial fractions. One partial fraction is using x minus 3. Another partial fraction is using x minus 3. Equal any letter, A, B, C, A, and B. So far, everyone follow me?
Yes.
Yes.
Cool. Now I try to eliminate the denominator. So you find the least common denominator, LCD, is x minus 3, x minus 2. And you multiply this expression by this. It's obvious. And when you multiply this in the left-hand side, stay alive only x, no? Because this and this is cancelled, and this is cancelled, no? Stay alive only x, is the part in the numerator. However, in the right-hand side, one is different. Is a times x minus 2 plus b times x minus 2. The supposition is clear. This cancel out with this, and this cancel out with this. Okay. Nice. I like that because this new expression do not contain denominator. I clear fractions. So I focus it in this. I try to find the smart value. Who helped me to select the smart value? Who helped me? What smart value you see? Remember, smart value is a x value. When you plug it in our expression, at least one guy is gone, disappear, it's 0. So what is the smart value that you consider is useful? This example. Huh? No idea.
Positive 2.
Very well. Positive 2, right? Positive 2, no? Exactly. Plug it in. You replace x for 2. 2 is equal a times 2 minus 2 plus b times 2 minus 3. 2 minus 2 is 0. Therefore, my expression is 2 equal. Entonces 2 minus 3 es negative 1. Entonces es minus b. Therefore, b alone is minus 2. If you want, you take the eraser and you erase this and you put minus 2 here. Because I found big value. What more smart value you can see? What more smart value you can see?
Positive 3.
Positive 3, very well. So positive 3 is 3, you replace x for 3, a times 3 minus 2 plus b, 3 minus 3. 3 minus 3 is 0, that part disappears, 0. And 3 is equal, and 3 minus 2 is 1, this is a is 3. You erase this, and you replace 3 for a for 3. This is what is my final answer. My final answer is then. This expression we given at the beginning gets x over x squared minus 5x plus 6 is algebraically equivalent 100% to two easy partial fraction. The first is 3 over x minus 3. This negative, personally, I don't like, can you put here? Much better, in my opinion, and the calculus way is put in the front. You know it's equivalent. So when you have a fraction, 2 over 5, see one number is negative, it's equivalent to say negative in the bottom or negative in the front. This idea is clear, right? And it's my beautiful final answer. Everyone understand very well?
Yes.
Okay, fantastic. Do you understand the case number 1? Can I repeat again? Case number 1 is when you are doing the factorization of the polynomial in the denominator in the bottom. You have linear non-repeated factors. Linear, non-repeated. Linear, remember, is degree 1. Linear. Let me complicate your life now. Suppose that you have the case 2. We have unfortunately, we have 4 cases. Suppose that we have case 2. Case 2 is repeated. Linear repeated. Linear repeated. Suppose the case 2 is when a q, remember I call q the polynomial in the bottom, has repeated. Repeated linear factor. Okay. One example can illustrate very well this idea is, suppose example 3, no? Is x squared divided by x minus 1 squared x plus 1. Okay, cool. This is a q. This is a q. I don't care too much p. So the polynomial in the numerator, no, it's not important. Well, it's important, but to classify is it case 2 or case 1, you focus it in the polynomial q. Now I see that we have repeated because we have x minus 1. You can write like that, x minus 1 times x minus 1 and x plus 1. So actually we have this is repeated because it's the same twin brother repeated, and this is not repeated. Okay, so it's no purely case 2. It's in the middle between case 2 gets repeated and non-repeated case 1. But we using both together. Look, let me show you how. The typical format for the partial fraction decomposition, you need to learn this, is you break it down, in this case, 3 partial fractions. The first one is x minus 1 squared. Exactly like that. The second one is x minus 1 to the power 1. Okay, power 1, you know, is completely invisible. So it's totally useless to write this. And x plus 1, okay, it's non-repeated. Ajá, entonces the question will fly in the air. Bueno, professor, pero well, suppose que it's another scenario. Suppose que you have x minus 1 cubic. And you have x plus 1. Entonces different is you copy several partial fractions and you, in the first one you write x minus 1 cubic. And the second you have x minus 1 squared. You decrease in the exponent 1, x minus 1 to the 1 power. And finally, don't forget the other case non-repeated case x plus 1. Do you understand? So you take the exponent and you start for the same exponent 2, 3, whatever, and you decrease it by 1 until 0. So no, disappear. Okay, so the rest is ABC because we have 3 partial fractions. Do you understand the idea for this non-repeated? At least the format. Do you understand or no?
Yes.
Yeah, cool. Now you find the least common denominator. Always you find the LCD. LCD is the combination, any factor in the denominator. However, how many factors I take? 3 or 2? No, 2, only 2, because the idea behind least common denominator is you take every factors, and see there are some factors that get repeated, you take the majority of them, not all of them. So actually LCD would be then x minus 1 squared and x plus 1. You take as the collection, LCD you form a guy, this is the back of the LCD. You take x plus 1, you put inside the back. And in between x plus 1 squared and x plus 1, oh, you take only 1, but you take when you have majority. So you take another x plus 1 inside the LCD. This is not the least common denominator. It's the common denominator, but not the least. So the rule is clear. You take, to form a least common denominator, every factor in the denominator, no omissions. You omit one, you are in big trouble. No good. However, when this is repeated, you take the majority. Majority is the higher exponent. And the other, que is small exponent, you totally mentally delete. Chan, chan. No good. Okay? Mentally delete. This is a classical. This is the elementary algebra. The definition for the LCD. Okay, I want to recall because always it's confusing. No? You multiply everything by this. Sure. Es obvio que in the left-hand side, stay alive only x squared. Correct? And now on the right-hand side, we have 3 guys. Well, in the first multiplication, you eliminate this and this. And stay a times x plus 1 plus b. And the second, you eliminate x minus 1, but one time. Can. And stay a 1x minus 1 because you have 2 in the LCD and x plus 1. Plus, in the last one, let me use another color, maybe green. You eliminate this, 2, and this, and stay alive only c times x minus 1 squared. Guys, do you understand this or no? Honestly. If you want, I explain step by step. Do you understand or no?
Yes.
Okay, nice. Just one more time. The problem is, now this is a complication. We need to find A, B, C. We need to find 3 numbers. However, how many smart value we have in my problem? Remember, smart value is the value okay, when you plug it in, maybe doing 0, 1 expression. No? Suppose that I take x equal 1 intentionally. Because I know that 1 here, 1 minus 1 is 0, and 1 minus 1 is 0. I take only A. It's doing 1 squared, the 1 is equal A times 1 plus 1. Here is 1 minus 1 is 0. That part is gone, and that part is gone. Do you see this or no? Yes or no? Now, 1 plus 1 is 2. This is 2a. And 1 squared is 1. 1 is equal to 8. Therefore, a is equal to 1/2. Divided by 2, 1/2. Okay, this is equal 1/2. After I want to express it and get it away, but at least I know it's 1/2. Okay, cool. Now we have another small value. Of course, we have another small value, que es -1. Because when you plug in -1 here, look, -1 plus 1 is 0. And here also, -1 plus 1 is 0. So disappear the A part and the B part. And stay alive the C part. Okay, I like that. Let's do another smart value. Let's continue here. This is -1 square is equal. That part disappear. That part disappear. Because -1 plus 1 is 0, and that part no. This is C. -1 minus 1 is square. And -1 square is +1, and -1 is -2, and -2 square is +4. Therefore, C is 1/4. So I copy here. C is 1/4. 1/4. Cool. But I have no B. I have no more smart value. My problem? Okay, no problem. Remember, this is a shortcut. Not always you can apply. So one possibility is using frame value. Frame value. What is the frame value? Frame value is, you know, arbitrary value. 2, 3, 4, 5. -1. No, -1, no. -1 I take. But I prefer 0. It's easy. X equals 0 is good frame value. I love this frame. And substitution. But be careful because I know I take advantage. Okay, you know the value of the A. That value is, you know the value of the A. You know the value of the C. And I focus only in B. Suppose now x0. 0 squared is equal A, que es 1/2. No A anymore, es 1/2. Paréntesis, 0 plus 1. Plus B. B, I don't know. 0 minus 1. 0 plus 1. Plus C, que es 1/4. 0 minus 1 squared. Everyone follow me? O sea, I take advantage que I know A, I know C. Y I assume X equals 0. Entonces, what is the only unknown that we have in the problem? B. Let's open. 0 squared is 0. 0 plus 1 is 1. 1 times 1/2 is 1/2. Plus. I don't know si es plus or minus. 0 minus 1 is -1. And 0 plus 1 is 1. And -1 times +1 is -1. And actually it's no plus, it's minus. Minus B. Plus or minus, I don't know. 0 minus 1 is -1, but -1 squared is +1, it is 1. Okay, easy. Therefore, B alone. Suppose I move, there are many ways to solve that. Suppose I move B to the right hand side, B alone. B plus 0 is B. S equal 1/2 plus 1/4. This common denominator is 4. So we have 2 plus 1. It's 3/4. Bang! And B is 3/4. Okay, nice. I like that. Then, B is 3/4. And I almost finished. Let me put it in elegant way, ready to continue calculus. Okay, the expression is given at the beginning was x squared over x minus 1 squared, x plus 1 is equal 3 partial fractions. The first one is x minus 1 squared. The second is x minus 1 linear. And the third is x plus 1. And I discovered A, B, and C value, okay, 1/2. So there are many ways to do that. One way is put 1/2 here. It's okay, it's a second. But however, in calculus, much better, you put 1 here and 2 in the bottom. It's the same. And 3/4 is 3 and 4 here. And the last one is 1/4, get 1 and 4 here. Boom, super cool answer. Partial fraction decomposition. Ready to continue calculus. Any question, all right?
No.
No? Okay. Of course, I bring a non-complicated example. This is relatively easy example numerically. However, when you are doing the homework, you can find a little bit complicated. Remember, I am available for you anytime. You send me a problem, I solve for you, but I solving problem of the homework, never solving problem of the test. Yeah, detecting me is test problem or it's homework problem. Okay? So this is the way I consider in my mind that you study. You study doing the homework. You study doing the homework. The homework I left you and the Alex. Okay, one more example. One more. I have two more. Let me see how many. Yeah, 2 more, no, 3 more. Okay, let's do it. Okay, I want to complicate more this. Look. We have the case 3. In the case 3, we look at that. We have Q, que es el polinomio que focusing, contains non-repeated, okay, nice, non-repeated, but irreducible quadratic factor. Quadratic. What means irreducible quadratic factor? Another factor, suppose like that. X squared plus 4, x squared plus 1, x squared plus x plus 1. Then when you analyze the solution, the zero of this polynomial is complex or imaginary. Okay, so irreducible quadratic is que you never can factorization using linear. And one of the only possibilities include complex or imaginary number. No, never we use complex or imaginary, at least in that. Let me bring one example to illustrate this idea. It's similar but a little bit format, different format. Look, suppose I bring this example. Example, what is the number of the example? Example 5? Example 5, no? Yeah, 4, 5. Example 5 is 3x minus 5 divided by x cubic minus 1. See? Wow, professor. What should I do? Well, it's always the same. You take the polynomial cube, get this, and you factorization. So you have to remember the famous formula for the difference of cubic. It is a minus b, a squared plus ab plus b squared. I suppose you remember or no? You don't remember. When you see, you remember, right? Yes or no? But the factorization, this is equal x minus 1 in this case, because a is like an x and b is like a 1, x squared plus x plus 1. And the top, no, I don't touch. Stay the same. So step number 1, do the factorization of the polynomial in the denominator. In this case, I realize it's the difference of a square. The square, no cubic, sorry, it's difference of cubic, and the factorization difference of cubic is formed by one binomial and one trinomial. And by the way, the binomial is linear, but the binomial no is prime, therefore it's typical irreducible quadratic ratio. Okay. So I refresh your memory, that part. Now, I explain now the format. When you have irreducible quadratic, so you have two partial fractions, decomposition. The first one is using x minus 1. It's this factor, nice, it's linear. Okay, it's linear, degree 1. And the second, no, irreducible quadratic. Okay, entonces you copy x squared plus x, because I try to do my best in the factorization of this, include complex number. I don't want using never complex number. No. The format is, you call this A, but this is different because it's quadratic. Entonces es bx plus c. The reason que es like that is because when you are doing the division, the degree of the remainder always is less than 1, the degree of the divisor. So when you are doing the division, see the degree here is 1, the degree here is 0, que is a number. However, the degree here is 2, the degree of this is 1, okay, linear. So now basically I need to find 3 constant, que es ABC. Do you understand very well the format? Yes or no?
Yes.
Yes.
Okay, let me try to do my best. Now, one more time, find the least common denominator. One more time, I find the least common denominator. Okay, obviously is both factors together. And when you multiply everything by the LCD in order to eliminate the fractions, well, you have in the left-hand side, you have 3x minus 5. But in the right-hand side, we have two fractions. We have a times x squared plus x plus 1 plus bx plus c times x minus 1. Okay. Okay. My question now is, we have a smart value now? Because sometimes happen that you have no smart value. But in this case, I ask you, we have a smart value or not? Remember, one more time I explain. Smart value is the x value. And when you plug it in inside the expression, at least one term disappears. It's going 0. Who see a smart value? See, it exists. Maybe do not exist, professor.
Positive
Positive 1.
Positive 1. Very well. Positive 1 because when you plug in 1 minus 1 is 0 and that part is 0, disappear BC and stay alive only A. So 3 times 1 minus 5 is equal to 8 times 1 squared plus 6 plus 1. And that part I don't write because I know that 1 minus 1 is 0, is 0 multiplied by everything. 3 times 1 is 3, and 3 minus 5 minus 2. Here we have 1 plus this is, I put x is wrong. It's x is 1. Actually, we have 1 plus 1 plus 1 is 3. Therefore, A is negative 2/3. A is negative 2/3. Okay, fantastic. We have another smart value? No. Why no? Because that part, the zero of that part is complex. And the real field, we have no smart value. But I'm using frame value. Frame value is 0, always, because it's easy. Substitution 0. Let's see what happens. A is 3 times 0 minus 5 is equal to A, but I know who is A. A is negative 2/3. 0 squared plus 0 plus 1 plus B times 0. Let me go with B times 0 plus C and 0 minus 1. Okay, this is negative 5. It's obvious because 3 times 0 is 0, no? And minus 5. And so now we have minus 2/3 because this is 0 plus 0 is 0 plus 1 is 1. That part is just 1. And 1 multiplied by everything is the same value. Plus B times 0 is 0. That part disappears. And 0 minus 1 is negative 1. So actually we have minus C. Minus C. Okay. Therefore, C alone. Let me try to do my best. I move C to the right hand side, opposite sign positive. Is equal 5 minus 2/3. So I move 5 to the left, to the right hand side, like a positive, opposite sign, and negative 2/3 stay. Here. This common denominator 3. 3 times 5, 15 minus 2, 13. Over 3. C is 13. I finished. Of course I finished. Because I found ABC. A is... No, I don't. I need to find B. I need to find B. No. I found only A and C. But B disappear here. No. What should I do? Well, one possibility is apply another frame value. Okay, I select always guide. No 100, no 50, no 45. It's a small value, close to 0. Just add negative 1 maybe. It's good. Okay, and take advantage. Okay, I know I have in my hand A and C. I'm plugging in here in this expression again. But plugging in x equal negative 1 under the consideration that you know A and you know C. And my only unknown is B. So 3 times negative 1 minus 5 is equal minus 2/3 negative 1 squared plus negative 1 plus 1 plus B, que I don't know, paréntesis, times negative 1 plus C, que es 13 over 3. And this is negative 1 minus 1. And that's it. The only unknown that we have is B. Okay. This is negative 3 and negative 5 is negative 8. Okay, that part is, you know, negative 1 and positive 1 is cancelled, and negative 1 squared is positive 1, multiplied by negative 2/3 stay negative 2/3, plus no minus. All right, let me see, I don't know. Is, well, actually is minus B plus 13 over 3. Times negative 2, no? Because negative 1 and negative 1 together is negative 2. Okay. Now apply distributive property is plus, because negative times negative positive 2b. And this is 26, no, minus 26 over 3. Okay, cool. Now solve for b. X minus a plus 2/3 plus 26 over 3 is equal to b. Let me condense in this fraction. Least common denominator 3 is minus 24 plus 2 plus 26 equal to b. To say 26 and 24 is 2, and 2 plus 2 is 4. It's a 4. Final answer divided by 2 both sides. 4 over 2 times 3 is equal to b. Reduce 4 divided by 2 is 2. B is 2/3. Guys, do you understand very well this arithmetic part or no? Oh, it's raining too heavy here. It's raining also in your home right now.
About to.
Yeah. Do you hear the rain?
Yeah, we hear some rain.
Yeah. We almost finished. Don't worry. Now let me write the final answer. The final answer is then 3x minus 5 divided by x minus 1, x squared plus x plus 1. I just copy that part right. Is equal minus 2, 3, x minus 1. Remember, it's a fraction. Wow. Okay, this is the last problem that we are doing because the rain is too heavy. Plus b is 2/3 2x. Yeah. The problem is that my office, I have my office in the terrace, and the terrace, the roof is the aluminum. Of course, it's isolated aluminum. No? So when the rain is heavy, you hear the sound. But don't worry, I will finish now. I need to change. I predict this it's not raining, but it's okay. 2x over 3 x squared plus x squared. And c is also 13 over 3 x squared plus x squared. That is the difference. Look, this is A, this is B, and this is, yeah, awesome. Okay, guys, we finish. We continue next time without the storm. Bye-bye.
Okay,
Professor?
Yaniri, stay here. Yaniri Izquierdo, you hear me or no?
Yes, I hear you,
Yaniri?
Professor.
Okay,
I can hear you.
Stay. Let's see if it really stop a little bit. And stay when everything is gone. You stay. Stay 1 minute.
Okay.
Only 1 minute.
Okay.
Geraine, you hear me or no?
Yes, Professor, I can
Okay,
hear
okay,
you.
listen. The test number 3 I sent attachment
Yeah.
for you.
Okay, perfect. So I'll use that one.
Number one. Number 2 is, remember you have pending, and Mia also have pending the online test 1 and 2, no?
Yes.
Mia, you did the first, no? But you retake in order to improve your grade. So now, when, listen to me, when you consider that I extending for you the due date for taking test 1 and 2 online.
Till next Monday, would that be okay? Till next Monday?
Super. That exactly was my idea. I want
Okay.
to extend it right now to let me see in the calendar.
Okay, okay.
In the calendar is, wait a second. In the calendar is next Monday would be April 3rd. Yes or no?
Yes.
Cool. I extend it right now to April 3rd. No the homework, only the test
Yeah.
for attendance.
Okay.
Okay? We have a deal.
Okay.
Take
And
advantage. Take
and we
advantage this opportunity,
and
please.
we have access for the online test in Canvas?
Yes. Of course, yes.
Okay.
Any grade online or on paper, I post it in Pandas.
Okay, perfect. Thank
Okay,
you, Professor.
okay, guys. Take care.
Thank you.